This is the question. We are told that Sunrise Limited manufactures office cabinets for both local and export market. The following data relates to the cost of production of the office cabinet. So we have the selling price per unit of 10,000, the variable cost per unit of 5,000, and the total fixed cost of 50 million. Required in batches of 1,000 units. Determine the break-even point in units using a graph. Indicate the profit zone and loss zone in your graph. But B, we are told that the management of Sunrise is evaluating various production and sales level to determine the profit after tax. Assume a tax rate of 30%. Plot a graph indicating revenue and profit after tax. And the last part, we are told the management of the company is evaluating the effect of selling at various percentages above the break-even point. Determine above the break-even point, beginning from 0% and in batches of 5% change point up to 50%. Plot a graph depicting target revenue, target profit after tax, and the margin of safety. So first thing first, the question wants us to get the break-even point, but we show that information on a graph. And we are told that production, we present it in batches of 1,000 units. So already we have our selling price, which has been presented as numerical information, so we don't need to make any adjustments. So let's have our solution, and for us to be able to have our break-even point, remember we said break-even point occurs where total revenue equals to total cost and therefore profit is equals to 0. So it means that for us to plot our graph, I already showed you a sketch of the graph, and remember we said that for us to have the break-even chart, we must have the total revenue, we must have the total revenue, we must have the total cost, and we must also have the output. The fixed cost is part of total cost, so we can choose to leave it out, but if you wish, you can still include the fixed cost in the graph, it doesn't matter. So let's go and try to get our total revenue, but first things first, because we need the range of output, the question has not given us the range of units to be produced. So the first thing we can try to do is to try and compute the break-even point in units. Let's try to compute the break-even point. In units and see where it actually lies. After identifying where the break-even point lies, then we'll be able to, let me make this font bigger. Okay, so we need to get the break-even point in units. And remember what we said, that for us to get the break-even point in units, we need to take the total fixed cost, divide by the contribution margin ratio. We said that the break-even point in units is given by, we say the break-even point in units is given by the total fixed cost divided by the unit selling price minus the unit variable cost. So that is what we need to do. So I'll just, if you know how to use Excel, then we can just do that computation without having to write those variables separately. I'll just say equals to, I'll reference the total fixed cost because I already see that it has been presented as a numeric value in its own cell, so I don't need to make any adjustment. I divide by the unit selling price minus the unit variable cost. And just to be sure, sometimes when you use this approach, it can always give you confusing results. It is always safer to use brackets so that you are 100% certain, just for the sake of accuracy. So that we take the difference between the unit selling price and the unit variable cost gives us the contribution margin per unit. Then we take the total fixed cost, divide by that. And that gives us the break-even point in units, which is a break-even point in units is 10,000 units. So now that we know the break-even point in units is 10,000, we can actually develop a range of units, because that was the idea. We want to know the range. So I can have a range of running between 5,000 to 15,000, so that I'm able to get, I can have a range running between 5,000 to 15,000, because I already know the break-even point lies between that. But different people will choose different ranges. So let me start with 5,000 units. And I want to run it all the way up to 15,000 units. So if you want, you can just do it manually. Alternatively, you can just use the column. I run the series, a linear series of 1,000 all the way up to 15,000. Then that will give us the units from 5,000 units to 15,000 units. So the next thing now we need is the total revenue. I want to get the total revenue. I know that the total revenue is given by the unit selling price, which is 10,000, and multiplied by the number of units. So if I want to get the total revenue, I'll take the unit selling price, which is 10,000, and multiply by the number of units. But because I want to use the field series, and remember I've referenced this 10,000, and I don't want it to run as a relative reference. So I need to make this 10,000 to be an absolute reference. So I'll highlight the range where we have the 10,000. Then I just press F4 once. When I press F4 once, I'm able to make that an absolute reference. So that now if I want to get the other total revenue, I just use the fill option. And we can use the comma style so that it becomes clear. And when you click, you can see that it has actually taken the 15,000 units times the 10,000 unit, and that is that. So we've been able to get the total revenue. So the next thing we need now is the total cost. And remember, the total cost is given by the total fixed cost plus the variable cost. So if you want to get the total cost, we know the fixed cost is 50 million and the variable cost per unit is 5,000. So if I want to get the total cost, I'll say equals to the fixed cost, which is 50 million, plus the unit variable cost. So let me use brackets so that it becomes easy. I will say open bracket the unit variable cost of 5,000. I multiply by the number of units, which in this case is 5,000 per unit. But remember, because I want to use the fill option, I want both. I want the total fixed cost and the variable cost to be an absolute reference. Otherwise, it will not give us the right fill values. So everything else will be an absolute reference other than where we have the unit variable cost. So I'll highlight the range and press F4 so that I make the fixed cost to be an absolute reference. And also highlight the range where we have the variable cost, and I make the variable cost per unit to be an absolute reference. So once I've made the two to be absolute references, I want the units to be relative references so that we're able to use the autofill option. So once we've done that, now we just use the field series, and you can always confirm whether you've picked the right thing, and you can see that they've still locked it to the fixed cost plus the total variable cost. That gives us the total revenue and the total cost. But remember, in this question, we were told that production are in batches and one batch has 10,000 units. So in this case, if I wish, I can just convert the output in form of batches so that the batches will form my y-axis. So if the batches will form my y-axis, then I'll have the number of units. I divide by 1,000. I can just say divide by 1,000 because I don't need it again. I can just use the normal values. There's no problem. And in this case, this is 5 batches and I use the field series. So I'll have batch number. Production will be in 5 batches running all the way up to 15 batches. So that is how we'll have the number of batches. So with this information now, we can be able to plot our graph and try to get the break-even point. But even before we plot our graph, we should be able to identify the break-even point. Remember, we said break-even point is where total revenue equals to total cost. And you can clearly see that this is where we have the break-even point. So that even if we decide to plot our graph, then we expect the total revenue and the total cost to meet at the point where we have the 10 batches. So that is the expectation from the graph. So remember, in the graph, in the x-axis, we'll have the number of batches, and in the y-axis, we'll have both the total revenue and the total cost. We'll have both the total revenue and the total cost. So if I want to plot the graph, I'll just highlight the ranges that I want to be presented in the graph. I'll highlight batches, including the title. Then we have control. We also highlight the total revenue and the total cost. Once we've done that, then we can just go to insert. Then we tell Excel to recommend for us a proper chart. From the recommendation, we see through and see which chart best describes what we want. And you can see that there are two possible charts. We have the scatter chart and we also have the normal line chart. So I think the line chart is best for this because you can see that the two lines are intersecting. So once you are comfortable with this, then you can just say okay, so that we use the line chart. So this is our line chart. And from this line chart, we can make it clearer. We can increase our axis values and components so that it is very clear. Then we also have our y values. Remember, in the y-axis, this is where we said we have both the total revenue and here we have both the total revenue and the total cost. And you can see that if we are to pinpoint where the two lines meet, you can see that within our area, you can see that that is where the total cost is equals to the total revenue. And we have exactly 100 million. So this is where our graph break even. So it is now very true and clear that this is our break even point. So now that we've shown the break even point, remember our question wanted us that we determine the break even point using the graph. And once we've determined the break even point, we show the profit and loss region. So how do we do that? So this is how we'll determine this break-even point. So we can actually highlight and clearly show. Let's try to show that this is the break-even point, and let's try to show that this is the profit region. Any region above the break-even point is the region of profitability, and any region below the break-even point is the loss region. So for us to show this, we can actually use shapes to highlight it. We can use shapes, and shapes can easily be manipulated to show so that we get what we want. And when you try to manipulate this shape, then we can use it here to show our loss region. We can use shapes to show the loss-making region. Then let's try to insert it there. We can resize it so that we don't interfere with the two lines. So once we've done that, we can try to change the fill color and make it. We can give it red, then we change the gradient so that we can make it slightly transparent by adjusting the opacity so that is our loss region. So once we've made that our loss region, we can use this same shape. Let me copy it so that I go and adjust it the other side. And let's use this to show the region of profitability. Can resize it down slightly. This is our profit region, but now let's give it a different fill color to make it. So this is our region of profitability. And this is the region of making losses. But we have to show clearly the two regions. So the other thing we can do now is probably solve that. I think that's it. We don't need to spend much time on that. We can now show that it is the profit region or loss region. So let me see how we can best present that. Let's go to our shapes and try to look for something. Okay, we can use a normal arrow. We don't need to. Let me look for a better shape that we can use for that, a pointer. So let me see. I can make it black and probably you can resize it. Then we can now point here. So once we add that pointer, we can make a copy of these pointers to show the different regions. So we can say copy and paste. Let me try to copy it again. Copy and paste. Then let me move it this other side. I want to show the region of profitability. This is the region where that is the profit region. Then we can also show the break-even point. Can show the break-even point. can show the break-even point. And this is the break-even point. Okay. Now that we've shown these points, let's try to rename them so that it is very clear which region is where we can insert. Let's see whether we can insert a text. So we'll introduce a text box. And in this text box, I'll call this. Let me undo that and introduce the text box. So if I introduce the text box, so I'll have the profit. This is the loss region. This is the loss region. Or we can say the loss zone, just like the question said it. The loss zone. Can make our text bold and increase it in size. So that is the loss zone. Can copy it and bring it here and say the profit zone. Profit zone. And we can also copy this and say the break-even point. So we can. The reason why I'm pasting it outside is because sometimes when you copy paste it inside the plot area, it gives you some error. So let me call this the break-even point. Let me call this the break-even point. Break-even point. So this is our break-even point. Let me undo that. Then our chart, we can give it a title and say break-even chart. Can give it a title and say break-even chart showing the profit and loss zone, probably something like that. Profit and loss zone. Break-even chart showing the profit and loss zone. Make it bold, increase the size, and that's it. Something like that. Now the chart is communicating, and we've shown. Remember, our question was that determine the break-even point in units and in shillings using a graph. So, and we know that this is our break-even point. So we can actually add labels to it so that we can see that that is the break-even point. And you can see we have the break-even point is where the company produces 10,000 batches and it has 100,000. If you wanted to give the X and the Y axis titles, I think I should have said that if I wanted to give these titles, then I can just click and go to the axis title. Under the axis title, then I can be able to have the primary title, and I'll call this number of batches. So we can have that as it as number of batches. Can have it as number of batches produced. Number of batches produced. of batches produced, that's okay. You can decrease it. If you wish, you can also give titles to the y-axis. The y-axis, remember, is where we add both the total revenue and the total cost. So I can just go and add the axis titles, and this time around is the horizontal. Under the horizontal axis, we can have the total cost and total revenue. So we can have the total revenue stroke the total cost. If you wish, you can write it in full. There is no problem still. Total revenue stroke total cost. And probably we can reduce this so that total revenue and total cost. So you can always make your graph better depending on what you want to do. So generally, this is how we show our break-even point using a graph, and also show the loss zone and the profit zone. And this is how we answer part A of the question. The next part, we are told that the management of Sunrise is evaluating various production and sales level to determine the profit after tax. We are told, assuming a tax rate of 30%, plot the graph of revenue and profit after tax. The question wants us to plot a graph of revenue against profit after tax. So I can just move this one down and move this one down so that I can have it just below here. There's no problem. So the question wants us to plot another graph of revenue against the profit after tax. We already have the revenue. So what we need is the profit after tax. What we need is the profit after tax. So for us to plot the profit after tax, we first of all need to compute the profit after tax. And if we go back to our board, we said that the profit is given by the contribution margin per unit. You multiply by the total number of units minus the fixed cost. So this was the profit before tax. So if you had to bring in the element of tax, then we can say the profit is given by the contribution margin per unit. You multiply by the output, you minus fixed cost, then you charge tax, and this tax is 1 minus T. For this, the same as saying profit after tax is given by, you take the profit before tax, then you say 1 minus tax. So the moment you minus tax, what remains is net of tax. And remember, the unit contribution margin, we say it is given by the unit selling price minus the variable cost. So we can actually do this computation direct in our Excel and still be able to get this profit after tax. So let's go back and try to get the profit after tax. So instead of having several working separately, I can just say the profit after tax is given by the unit selling price, which is P, minus the unit variable cost, which is B. And the difference between the two gives me the unit contribution margin. Then you multiply by the output. So let me have the two in bracket. So I say open bracket, then close bracket. If you're not comfortable with brackets, you can always have them in the independent cells, whichever works for you. It is up to you to decide. Then you multiply by the unit. This gives me the total contribution. From the total contribution now, I minus the fixed cost. So that if we say minus the fixed cost, then I'll say minus, and we know that we already know that the fixed cost is 50 million. And whatever I get, after getting all that, I less corporation tax, and we know that corporation tax rate is 30%. So maybe before doing any adjustment, let me just say, if I was to say, okay, at this point, this is what you get before adjusting for tax. So if I want to adjust tax, then it means that I can still use bracket and say everything in the bracket, open bracket. Then I close the bracket, I multiply by 0.7, because when I say 1 minus 0.3, I get 0.7. So I can just multiply with 0.7 direct. So that at this point, the profit after tax is that. So we have a negative 17 million, which is actually a loss. But remember that I want to run this through relative referencing, and you must never forget that. So which means that I need everything to be an absolute reference other than the number of units. And the number of units in this case is in which cell? This is in cell B24. So I need all the cells to be absolute references other than B24. So I'll highlight the range and press F4. I'll also highlight the second range and press F4. I'll also highlight the third range and press that is, we are saying that is which one? That is C7, which is the fixed cost. I press F for fixed cost is C7, that one is okay. Then I press OK. So now that I've made all these absolute references, just double click. And when you double click, you can see that now I'm able to get the profit after tax, and at the break-even point, that is where the company starts being. That is where the company has a profit of 0. Then from there, it starts being profitable. So now that we have our profit after tax and our revenue, we can now plot these two on the graph. Remember, the question said that plot a graph showing the revenue and the profit after tax. So now that we can just highlight the range for revenue and control and also highlight the range for profit after tax, but we want it against the number of batches. Remember, the constant production in our x-axis is the number of batches, so we can highlight all the three. Otherwise, it will give us misleading results. Then go to insert, and then we tell Excel to recommend for us a chart. Then we try to see which chart best describes our data. Now we can use the line chart, because at least from the line chart, we can clearly show the total revenue and the total cost. And from our line chart, this is how we present our data, so that we can also increase the size so that we're able to see them clearly. So that is that. So now that we have our graph for total revenue and the profit after tax, and you can see the one in blue is the revenue, the one in red is the profit after tax. And you can actually see that where we have a revenue of 100 million, that is where our profit after tax is actually 0. And that is the break-even point. So from this point, this is where the company starts being profitable. The same case applies to revenue. So with the formatting, I've already shown you how to do the basic formatting. Once you've generated your charts, you can always now just make it visual. So that's it for part B of the question. And part C, we are told that the management of the company is evaluating the effects of selling at various percentages above the break-even point, beginning from 0 and in batches of 5% change point up to 50%. Plot a graph showing the target revenue, the target profit after tax, and the margin of safety. So in this case, the management is evaluating if they were to increase their selling from 0 to 50% above the break-even point, what is likely to happen to the target revenue, the target profit, and the margin of safety. So let's try to have that. And we can just have, let's say that we have the change and we are told to start from a change of 0. So at point 0, this is where we have our break-even point, which is 0%. And we want to show the change. We are told to show it from 0, but there is a 5% change all the way up to 50. So if there is a 5% change all the way up to 50, let's see if we can use the fill series for that. But if you can just enter it manually, there's no problem also. You don't need to complicate things. So let me say this is 5%, and I want it to run all the way up to 50%. Okay, that one is still okay. So we have 0 to 5 to 10 all the way up to 50, and that is what the question is telling us. That beginning from 0% and in batches of 5% changing all the way up to 50. So remember at 0, the company had certain number of units, and it also had certain number of batches on those units. So the question wants us to get the target revenue, the target profit after tax, and the margin of safety based on this. So we need to get the target revenue, the target profit after tax, and the margin of safety. Remember, we mentioned margin of safety in our brief introduction class to CVP analysis. Okay. So now that we have all this, let's go back to at 0% where we were at break-even point. Remember, at break-even point, we had 10,000 units. And the 10,000 units had 10,000 batches. We had 10,000 units, not 10,000 batches, but it was 10 batches. Sorry for that. Because remember, the 10,000 units gave us 10 batches because it was 1,000 per batch, but we'll come and adjust that later on. So what is the question telling us? If the number of units that is being sold was to increase by 5%, what is likely to happen to the target revenue, the target profit after tax, and the margin of safety? If it was to increase by 10%, what is likely to happen? All the way up to by 15%. So we just need to create a function that allows us to run through everything through relative reference. So the current state or the current position at break-even point is that we have 10,000 units. So if the units was to increase by 5%, remember the 0% actually implies that at this point we are operating at 100. We are at 100%. And this 100%, so there's actually a 5% change. Remember, we talked about sensitivity analysis within the context of CVP. So ideally, the 0% means it is actually at 100%. And it increases because you are told that above the break-even point, so that it is 5. If it is 5% above the break-even point, then at this point it means that it is 105%. If it is 10% above the break-even point, then it is 110%. If it is 15% above the break-even point, then it is 115%. And if it is 50% above the break-even point, then it is at 150%. So that we can get what a 5% change in units sold will have on either revenue, profit after tax, or margin of safety, or a 50% change in units sold will have on the three. So for us to do that, we can actually say that if that is 100%, then we can say equals to the current production at break-even point, we multiply by, because I want to express it against the 100% and not the 0, so I can use open bracket 1 plus the 5%. So that now when I close the bracket, I'll show how the units increase. So that will be the 10,000. If it increases by 5%, that will be 5%. So that will be 10,500. So 10,500 is actually 5% above the break-even point. So that if the break-even point had 10,000 units, then 5% above the break-even point will have the 10,500 units. And that is what we need to do the same for all the rest. So what I can do, because it will always be charged above the break-even point, so I can make this base of 0 to be an absolute reference. So that I want to charge everything on the 10,000. So that if I make this an absolute reference, then I can highlight the range where we have 10,000 and press F4. So the reason why I'm making it an absolute reference is so that if I use the field series, you can see that it is now 10% above the break-even point, 15% above the break-even point, 30% above the break-even point, 40% above the break-even point, and 50% above the break-even point, which is actually 150%. And even if you are to do this manually, you can see that when you take 150% of the 10,000, you actually expect to have 5,000 units above the original, which makes it to be 15,000 units, which is actually making sense. So based on these units, we can get the batches by just saying equals to the number of units divided by 1,000. So that in that case, I have 10 batches all the way up to. We can increase the decimal places because of how close they are. So let's say increase the decimal place so that we have a clear distinction. So now that we have that, we can get the target revenue. The target revenue, we just know that we take the units times the selling price. Remember, the selling price is constant, so I'll just take the number of units I multiply by our selling price, which is still 10,000 units. 10,000 shillings per unit, not 10,000 units, but 10,000 shillings per unit. And because I want to use the field series, I can do that and just lock that and press F4. So that when you press F4, then now we can be able to get for the rest. And you can clearly see that it is still 15,000, it is still locked to the original 10,000, which gives us a target revenue of 150 million. Then the next one is the target profit after tax, which we said the profit after tax is given by the unit selling price minus the unit variable cost. Then we multiply by the number of units. So that the number of units in this case we have is 10,000. That will give me the total contribution. After getting the total contribution, we minus the fixed cost. The fixed cost has not changed. The fixed cost is still 50 million. But remember, we are saying profit after tax. So first things first, we need to make all these absolute references just like we did before. We need to make these absolute references. Sorry for that. Let me just repeat that calculation again. We are saying we take the unit selling price minus the unit variable cost, then everything else in bracket. We multiply by the number of units, then we minus the fixed cost. The fixed cost is 50 million. So I can just highlight the range and make this to be an absolute reference. And I'll also make the unit variable cost absolute reference. and the fixed cost, I'll also make it to be an absolute reference. But because I'm also charging tax, so what I'll do, I'll put everything in one single bracket. So I'll go back and add another bracket, open bracket. Then I close the bracket. I close the bracket and I multiply everything by 0.7 so that I have it net of tax. So that will give me the profit after tax. And you can see that the profit after tax is still 0. Then we use our field series and we can decrease our decimal place. Then the next thing we need to get is the margin of safety. Remember, we said the margin of safety is the difference between the actual output against the budgeted output. And we said you can be able to get the margin of safety, you can get them in units, or you can get the margin of safety in revenue. If you want to get the margin of safety in units, you can get it in units, or you can get the margin of safety in shillings or in monetary terms. There is no difference. So if I want to get the margin of safety in units, remember what we said. We said the margin of safety in unit is given by the actual minus the break-even point, the break-even units. And in shillings, we take the break-even revenue minus, the actual revenue minus the break-even revenue. So if you want to do that, then we know that this is the break-even units, and this is the break-even revenue. So if you want to get the margin of safety in units, then we'll take the actual units, you minus the break-even units. But because I want to log the actual against the break-even units, so the value that I'm subtracting, I can make this value to be an absolute reference by pressing F4, so that everything else will be charged on that, while the rest is a relative reference. And you can clearly see that when I double click on that, everything else is on the 10,000. This is 13,500 minus 10,000. This is 15,000 minus 10,000. This is now our margin of safety in units. You can get our margin of safety in shillings by taking the actual revenue minus the break-even revenue. So we'll just say equals to the actual revenue, which means at this point, the actual revenue is the same as the break-even revenue. That is why I'm subtracting the same value. But the value that I'm subtracting against is what I'm making an absolute reference by pressing F4. So that then now I just use the field series. And if you cross-check, you can see that this is 115 against 100. This is 140 against 100. And finally, this is 150 against 100. And that is how we get the margin of safety. And we are told to plot on a graph. So once you have the values, now you can easily plot them on a graph. The question wants us to plot the graph showing the total revenue and the margin of safety. So we can actually highlight, the question has not told us the margin of safety based on what. So in this case, there's no problem. We can use the margin of safety in monetary terms, there's no problem. Then we also pick the target profit and the target revenue. Then once we picked those, then we can also have it against our number of batches. Let's see if that will communicate. Then we'll go and tell Excel to recommend for us the best chart. Let's see whether we have a chart that is making sense. So the line chart is actually making sense. Let me see if the line chart is making sense. So we can still use the line chart because you can see that it has the line showing the target revenue, the target profit against the number of batches produced. So that one we can show that on a graph. Alternatively, we can still use, if you didn't want to use this, there's still an alternative approach because the question did not necessarily say that we have to show it against. Let me see if it was against the batches. Doesn't explicitly say that we have it against the budget. So what we can do alternatively, we can still run, we can still have, alternatively, we can still have our margin of safety and have our target profit and target revenue. Let's see whether we can have it as a column. That is what I'm trying to ascertain. Whether we can have it as a column chart. Okay, I think that one is not giving us a clear picture. There's one item I've left out, so that's okay. Okay, we can have it as a line chart, there is no problem. So that is how we present that chart. And all these are number of batches, so we can make it bold and increase the size. From there, now you just need to make your graph as visual as possible and as clear as possible so that it's able to communicate what you want. So that's it for that part on